Hello all, welcome back to my YouTube channel. Myself K. S. Ritani, studying in Sri Venkateshwara College of Engineering from the Department of Information Science and Engineering. Today in this video let us see about the topic permutations from the subject Discrete Mathematical Structure. Introduction to permutations. Permutations refers to arrangement of a set of objects in a specific order. It is a key concept in counting and probability, particularly when the order of element matters. In engineering mathematics, permutations are crucial for solving problems related to arrangement and sequences. Understanding permutations helps engineering in optimizing processing and resource allocations. For example, arranging the letters ABC, there are 3 factorials, that is 6 permutations, that are ABC, ACB, BAC, BCA, CAB, CBA. Here, for a set of n distinct elements, there are n factorial. In this slide, let us see a proper definition of permutation. A permutation is a set of arrangement of its members into a sequence or linear order. Here, the number of permutations is defined as n. Distinct objects is calculated using the factorial function. As told in the previous slide, it is denoted as n factorial, and it is the same example. The number of ways of an arranging n objects into ordered groups of R projects summarized by this formula. Factorial notation. Factorial notation represented as n factorial. It indicates the product of all positive integers up to n. For example, 5 factorial is 5 into 4 into 3 into 2 into 1, that is equal to 120. Factorials grow rapidly, which is important while calculating permutations for a large set. If n is a positive integer, then n factorial will be denoted by n factorial, and it is a product of all positive integers, that is less than or equal to n. It is defined by n factorial equal to n of n minus 1, n minus 2, and so on. But there is an exception, that is 0 factorial is equal to 1. Permutations of distinct objects. The formula for number of permutations of n distinct options is P of n, that is equal to n factorial. This means every arrangement of n items is unique, since all items are different. Distinct permutations are commonly used in scheduling and project management in engineering. Permutations with repeated objects. When the permutations have repeated objects, the total number of distinct permutations is less than if all objects were unique, because swapping identical items doesn't create a new arrangement. Here the formula used is n factorial divided by n1 factorial, n2 factorial, and this continues till the n number of objects, where n is equal to the total number of objects and n1, n2 till nk are the frequencies of objects repeated. Here, for example, balloon. In the word balloon, there are 7 letters. Here n equals to 7, and L appears 2 times and O appears 2 times. Then the distinct permutation will be 7 factorial divided by 2 factorial into 2 factorial. And when we calculate, we will get the answer, that is 1260. It happens for all kinds of permutations. Let us see the applications in engineering. Permutations are utilized in optimization of problems such as maximizing production efficiency. They play a key role in designing algorithms for routing and scheduling the task. Engineers also use permutations in resource allocation to ensure optimal use of materials and time. For example, communication systems. material science and manufacturing, computer engineering, civil engineering, chemical engineering. Now here let us see a simple example of permutation. Now, three different gears in a machine which can be done in six different ways. Here it means three different gears, that is 3 factorial. 3 factorial is equal to 3 into 2 into 1, that is nothing but 6. Here that is what it tells, three different gears in a machine that can have six different ways. For example, they all three are gear 1, it can be as gear A, gear B and gear C. Now they can be arranged as A, B, C, A, C, B, B, A, C, B, C, A, C, A, B and C, B, A. These are the six types. These are few other examples determining the seat arrangements for a team of engineers at a conference table in a telecommunication. Permutations helps in optimizing arrangement of signals for maximum clarity. Let us see about limitations of permutation. As the number of objects increases, the number of permutations grows factorially, making calculation complex. Not all the problems require full permutations. Sometimes combinations might be more appropriate. Engineers must be mindful of the computations limits while handling a large data set. Comparison with combinations. Unlike permutations, combinations focus on the selection of items without regardless order. The formula for combinations is C of n comma r, that is equal to n factorial divided by r factorial of n minus r factorial, highlighting the difference in the focus. Understanding both the concept is essential for engineering to choose an appropriate method for a suitable problem. Conclusion. Mastering permutations is a vital for engineer in various fields, including the operations and logistics. Knowledge of calculating and applying permutations, it leads to a efficient designing and processing. Engineers should continuously practice permutation problems to enhance their problem solving skills and techniques. Thank you.